Hello everyone, and welcome back to our channel. In today's video, we are going to talk about an important maintenance challenge in baghouse systems: corrosion in the top box casing, also in the clean and dirty gas plenum and top housing. This issue is more common than you think, and if not addressed, it can reduce efficiency, damage equipment, and shorten system life. So, let's look at the major causes of the baghouse corrosion and understand why it happens. Next, we will learn and understand the main causes of corrosion in baghouse internal components such as the casing, top box plenum, clean and dirty gas chamber, and other parts. Corrosion in the baghouse top box, clean air plenum, or top housing, is a common maintenance issue that can reduce system life and efficiency. Below are the main causes of top box corrosion. The first causes are condensation due to temperature fluctuation. The second causes are moisture ingress. The third causes are poor insulation works. The fourth causes are corrosive gas or acidic attacks. The fifth causes are air leakage from pulse valves system. The sixth causes are improper materials selection. The seventh causes are long idle, shutdown periods. The eighth causes are inadequate paint coating. The ninth causes are dust or ash deposits. The main importance notes. By ensuring proper sealing, insulation, correct material selection, and carrying out regular inspections with proper maintenance, corrosion can be prevented, and the lifespan of the baghouse system can be significantly extended. Next, we will learn and understand the main causes of corrosion in baghouse internal components such as the casing, top box plenum, clean and dirty gas chamber, other parts. The first causes are condensation due to temperature fluctuation. When the baghouse operates at high temperature and then cools down during shutdowns, internal moisture condenses on metal surfaces. This condensed moisture, water combines with fine dust and form corrosive or acidic deposits on interior surfaces. The second causes are moisture ingress. Inadequate sealing such as worn gaskets, loose bolted joints, or improperly closed inspection doors which can allow rainwater to leak into the clean air chamber. Moisture reacting with warm internal surfaces or gases creates condensation, which promotes internal corrosion of the baghouse. The third causes are poor insulation. Lack of insulation or heating in cold climates can cause dew point corrosion. Metal surfaces drop below the dew point, and acidic condensate forms, especially if flue gases contain SO2 or HCl. The fourth causes are corrosive gas and acidic attacks. Residual acid gases, SO2, SO3, HCl, HF, may pass through filter bags and react with moisture to form acids, like sulfuric acid. These acids attack, degrade the carbon steel and unprotected metal surfaces inside the baghouse. The fifth causes are air leakage from pulse valves system. Leaks in pulse cleaning lines or valves can release compressed air containing moisture or oil, leading to localized corrosion on nearby surfaces. The sixth causes are improper materials selection. Using carbon steel in corrosive applications results in early rusting and pitting. Materials must be selected based on gas chemistry, moisture levels, and operating temperatures. The seventh causes are dust or ash deposits. Accumulated fine dust can trap moisture, creating microenvironments that promote corrosion. Certain dust types, for example, fly ash with alkaline or acidic residues, further enhance the corrosive effect. The eight causes are long idle, shutdown periods. Keeping the system idle for long durations traps moist air inside. Without ventilation or purging, internal surfaces begin to rust even before the next startup. The ninth causes are inadequate paint coating. Paint or epoxy coatings may degrade over time due to heat, chemical exposure, or poor surface preparation during fabrication. Once the coating is damaged, corrosion accelerates rapidly on the exposed metal. The conclusion and quick summary of the tutorial. Top box corrosion mainly occurs due to moisture and condensation, acidic gas reaction with water, poor insulation and coating failure, dust deposits and air leaks, wrong material selection and long idle periods. If these factors are not controlled, the baghouse top housing corrodes prematurely, leading to costly repairs. To wrap up, corrosion in the baghouse is mostly preventable. By ensuring proper sealing, insulation, correct material selection, and carrying out regular inspections with proper maintenance, corrosion can be prevented, and the lifespan of the baghouse system can be significantly extended. If you found this video helpful, give it a thumbs up, share it with your team, and don't forget to subscribe for more industrial maintenance and baghouse operation tips. Thanks for watching and see you in the next video.